I'm going to do number 44 in chapter 8, just to show you how to find a regression line and interpret it and find the value of the correlation coefficient and R squared. So I've already entered the data to make it quicker. And this is years since 1965. So 0 is actually 1965, and 40 would be the year 2005. And this is birth rate per 1,000 women in the US ages 15 to 44. Okay, so love about fathom, drag down a graph. This is going to be my explanatory variable. This will be my response variable. And obviously we can see a trend, the association, direction, form, and strength. It's certainly negative. Is it straight enough? We've got a couple funky things going on here. Perhaps that's an outlier. And strength, I would say moderate. So let's go ahead and do a regression on it. So I find the least squares line. And there's the equation. So birth rate per 1,000, that's our y hat. And there's my slope, negative 0.11 times years since 1965, plus 18.17. There's a good example of the vertical intercept that would predict the birth rate at year 0, which in this case is actually 1965. Notice, what would you say about this residual? It's a positive residual. The data point is higher than the model point, so the model's actually under predicting. There's my R squared, 0.67. That means that 67% of the variability in birth rate can be explained by years. There's obviously all kinds of other things going on here. Who knew what happened here, right? Birth control maybe was introduced or became readily available. 1975. Okay, but really, what else should we check to see whether our model is appropriate? We should check the residual plot. So again, if I right-click and I go way down, I see make a residual plot. And here's my residual plot. And we want to check for things like, do we see a pattern? You could almost say there's a little bit of fanning here at the beginning. The model seems to get a little bit better as we go out. We should check the size of, if we decide that this is relatively boring and we don't see a clearly curved pattern, the fanning isn't obvious, we should check the size of the residuals. The largest residual is -2. Now we're talking about, a rate, a birth rate. So is 2 a large value or not? But other than that, again, that's an outlier. I'm not going to go through the business, but we could delete that point. I think in Fathom, actually, you can do things like that relatively quickly, but I forget how, so I'm not going to deal with it right now. I can highlight that point, 75, and I don't know if you can remove it temporarily. If I delete that case, let's see what happens. Yeah, R squared becomes 0.9. Things are a lot more boring, so to speak, in the residual plot, and our residuals are within 1 percentage point. So that is how you would create a regression line in Fathom. Get the line. Remember, it's basically y equals, in this case, they do give it to you an mx plus b. Statistic notation would give you your starting value first. So what about GeoGebra? Notice you'd have to get r by taking the square root of r squared here. So pros and cons to Fathom and GeoGebra. So I had a GeoGebra file. Let me close this one. I'm not going to save it. Oh, by the way, I think if I can undo that, deleting that case by just hitting Control Z or Command Z in Mac. But so you can readily go back and forth. I'm just going to close that down and we'll look at our GeoGebra file. And again, here I'm going to highlight these two columns. I'm going to come to two variable regression analysis. I'm going to say analyze, and it creates this new plot. And I can do a linear regression on that. Notice it's a lot more straightforward, the y equals mx plus b, but again in Fathom I like the fact that it's showing you birth rate depends on year. And then I believe, there's my statistics, there's r, and there's r squared. And, forget where I can get residual plot. Up here maybe? Oh, residual plot. And there's the residual plot. And again, you can see this guy down here, perhaps an outlier, sort of creating a fanning situation. Lots of times in statistics, we just say, okay, good enough. Some purists don't like that, but we're trying to describe patterns. They're very rarely perfect, so we have to decide if things are good enough. And again, we might choose to delete that outlier. But that's how you would get that. I like Fathom, you can see the two together. I'm not exactly sure how to do that on GeoGebra. But the fact of the matter is that you can get all of these things. Let's see. You can copy to graphics view. And let me go back to the scatter plot. And I can copy that to graphics view. And let's see what happened there. There's my scatter plot. I don't know what happened to the residual plot. Oh, and here's the residual plot down here. So you can look at it at the same time. I copied it to graphics view. But it all has to be on the same scale, which to me is less convenient. But there you go. In Fathom and GeoGebra, finding all the stuff you need. Notice though when you're back in the graphics view that you no longer see all of the statistics. In Fathom, you can actually, I could bring down a summary table and I could put, there's my years since, I can add, I might have to bring down a whole separate summary table for the birth rate. And if I click on this, I can add basic statistics. There's my mean, my standard deviation for that, for the years. So you can actually see the pros and cons of each. For this one, I mean, we could see all that statistics summary in one chart on Fathom, on GeoGebra. But all the information you can get via technology, which is why statistics is so fun these days. Okay, probably long enough.